All right, so this is my presentation on the arborist industry and getting you familiarized with it. I apologize, I don't have any of my physical props or gear that I would be using for my actual presentation for the skill because that's at another station. I am traveling over at this station for several shifts, and so I do not have that with me. But let's go ahead and roll into this PowerPoint. So the objectives, we're going to describe the history of climbing arborists. We are going to understand the different levels of competency in the arborist industry and why there is such a variance that you can find. We're going to talk about different rope constructions and what arborists tend to use, so you're aware of that. And then we're going to go through a bunch of different arborist specific gear so that you then can recognize what you're seeing when you go on site to an actual arborist rescue. So people have been getting into trees for as long as there have been people, and historically it's predominantly been to get food or to get to safety. Now, as people have evolved and time has gone by, they developed greater and greater techniques and tools for being able to get into trees and maneuver around beyond just their hands and feet. You can see that this person has straps that they've created, essentially a makeshift lanyard, and then a foot ascender for being able to get grip on the tree and be able to push against it and leverage himself up. In the Polynesian islands and other places, a lot of times you will still see people utilizing these techniques for getting up into coconut trees. We're going to go over some important eras in modern arborist, in the modern arborist industry. We have early 1900s, post World War II, 1960s to 70s, 1980s to 90s, 2000s, and then today. So in the early 1900s, this is when the profession of being an arborist really started to blossom. And before this point, it wasn't necessarily a company or an individual that was hired out. It was more so you happened to have a lot of trees on your land and you had somebody that would help you with that. So we actually began to have a profession created, and for the most part, the way that people would get up into trees was using a flip line and spurs, gaffs, whatever it might be called. And that would cause a lot of damage to these trees that people were trying to climb up and not end up cut down. So you had these trees being left behind with a bunch of gouges in the side of them, which wasn't great. And then most of the technique and skill was learned on the job through apprenticeships and such, and so there wasn't any real type of centralized knowledge base on skills and capabilities, and barely anything to say about safety. Here are some fun pictures, historical. So you have no harness, just a makeshift rope harness with nothing really in the way of safety, no helmet, anything like that. Here's another picture over here doing the same thing. And then here's some pictures of very large trees, people using those flip lines to be able to ascend up. After World War II, that is when you started to see a real increase in urbanization, a big push for public parks, large trees, helping the populace have something to look forward to and relax after the Great World War II. So there was an increased need for skilled arborists. And you started to see more and more people up in trees and being paid to do so. Spurs were still being used, but they developed this double rope technique, DRT, or the moving rope system, MRS, synonymous, they both mean the same thing. So instead of using spurs and flip lines predominantly to get up into trees, they were setting ropes from the ground and then getting on a rope to get up into the tree. What that resulted in is less damage to the tree and more safety for the climber, and also more capability for moving around the tree a little bit better. Here's an example of what that system looks like. And so if you could imagine that you have a branch or a redirect carabiner, pulley, whatever it might be, up here, you have your main line going up. It goes through this system. You have your rope grabbing portion. You have your pulley that will help to push this up as it moves. Line goes up, comes back down, and terminates back at this pulley. You clip into this, and so it's a moving rope system, because as you climb up, pull down on this rope, and the rope actually has a 2-to-1 built into it. 1960s and 70s, that's when you saw a significant beginning to the professionalism of the craft increasing in the arborist industry. You have synthetic ropes that were created that made it to where you had much stronger, more reliable, and much more flexible materials being used by arborists moving around in trees. They weren't using nearly as much improvised harnesses, as they were starting to use mountaineering and caving harnesses that were commercially produced, but then adapted to the needs of the arborist. ISA, the International Society of Arborists, was created initially back in 1924, but around this time in the 60s and 70s is when they really started to push a lot of training for safety and skills for arborists. And you started to see much more in what I talked about, a trend upward in the professionalism of the craft. You started to see a lot of that coming out because you started to have a much more centralized base of knowledge and skill being taught to people. And then this ANSI Z133 is the gold standard for what could be considered the only source of standards for the arborist industry. And that goes with techniques, gear used, as well as safety ideology. And it was created by a request from this Ethel Hugg, whose son had died while in a tree and was electrocuted while he was trimming that tree. So the mother recommended or requested that a safety standard was created, and a couple of years later it was. 1980s and the 90s was a really fun time in the arborist industry, because you started to see this huge surge in climbing competitions. The first climbing competition was created in 1949 in California by the Western chapter of the ISA. And this time, the 80s and the 90s, is when you saw a huge surge in competitions happening nationally. And then, here in the States, the first time an international competitor came over was from Europe, and that was in 1994. And then you started having competitions happening globally. What that ended up doing is you ended up having the skill set, the tools, and the mindset of an international crowd coming together and people teaching each other and sharing. And as always, competition fosters innovation, because you want to be better than other people, so you're going to innovate to be able to help yourself be better. You started to see a huge increase in techniques and gear being used in these competitions, and then also in arborist industry itself. So here's an excerpt from one of the ISA's publications, and this is a pretty historic excerpt. This is the first time that somebody in the arborist community decided to use a single rope technique, and this was adopted, this is him talking about it, this was adopted from cavers. This is called a frog system, and they started using this in trees because they noted it's a lot faster and easier to get up into a tree on this system. So you start seeing this multidiscipline focused practice coming together in the arborist industry. In the 2000s, you have a significant push in devices that are being created, and all of these are these two are rope grabs that are going to be progress capturing while you climb, and then they're releasable for you to be able to descend on. And this is called a rope wrench, where that just relieves force that you are exerting on rope so that you can use a friction hitch and your full weight on that to be able to lower yourself down. And here's an actual evolution of what was used by the original creator of the rope wrench. He started out with an actual wrench, and then he made wood models, and he continued on until we reached the current product. And there are a lot of different variations in that rope wrench design from different companies now. And today we have a lot of different technologies being utilized to be able to help arborists stay safe. So you have this sonic tomography and resistograph that will help to identify weak points in trees before anyone ever actually goes into the tree. That is one of the leading causes of injuries in trees, is unknown weaknesses in the tree that fail under load, and an arborist gets damaged, gets hurt in that instance. Also, drones being used to place throw lines in trees in very obscure areas or very tall trees. So the reason that we have a huge variation in competencies within the arborist industry is because there is no real requirement to follow the standards outlined in ANSI Z133, which again is really the only standard that's in existence for the arborist industry. The ISA has a bunch of classes and training for safety and best practices that are not required to be a climbing arborist. And so you have people who are just on rock climbing harnesses, going up into trees, and not really knowing what they're doing, not following best practices. And unfortunately, they are not actually required, like firefighters are, to have training that is approved by NFPA standards or other government agencies that adopt those standards. Here's a list of people on Instagram who are awesome in the arborist industry, and I have links on here that we could pull up their accounts if we had time. But I would recommend, if you ever wanted to learn more about the industry, follow these accounts. You'll see a lot of really good content. They all put out a lot of content. And then here are links to videos of the less competent people in the arborist industry and problems that have occurred. If we had time, I'd be able to click on these and show the videos. But let's talk about gear. So rope construction by itself is going to consist of a lot of different strands that are twisted together that are then either braided or twisted together on top of that. And you have Z strands and S strands. We're not going to go into how to identify which is what, but it's just to say that certain strands are twisted clockwise and other strands are twisted counterclockwise. And you use those opposing twists together to then result in a straight, non-kinking rope. If you had a rope that was completely made of Z strands or completely made of S strands, it would kink to high heaven. You'd never be able to utilize it as a really effective rope. And so you have these two opposing twists used to make all ropes. So actual rope construction, not an exhaustive list. You have twisted rope, which a very common one is 3-strand, which has been around for thousands of years. And you will have arborists use this large 3-strand twisted rope for rigging because it's a very strong build and it's very cheap rope. You can get a lot of it very strong for not a lot of money, and it lasts for a long time. You have single braid, which is basically just a hollow tube. And a lot of times what you'll see with that is they will splice it to have eyelets that you can click with a carabiner or two, whatever it might be. It's very, very easy and simple to splice. Double braid is just a tube that's inside of another tube. Firefighters in general, rescue rope uses kern mantle where if you've been trained in rope before, you know that 90% of the strength of kern mantle rope comes from the core, and then 10% of the strength comes from the sheath. For this double braid, it's shared 50-50. 50% of the strength is from the core and 50% is from the sheath. This is the type of rope that most arborists are going to use. Reason being is because it's still very strong. It is very supple generally. It's got a good bend to it, but it's also very easy to splice. So you can get these nice tight eyelets at the end that you can clip a carabiner to, and actually where tying a knot will make a rope 50% less strong. These splice ropes, when they're done according to manufacturer specifications, can end up being just about as strong as the rope is generally rated for. And so they like having that as well as the compactness of that single eyelet. So again, double braid is what arborists tend to use for their personal climbing line. This is going through all the different fiber types that are used in rope. If we had more time, we could go over all the different things. The ones that you will see the most often being used in rope: nylon, polyester, and HMPE, which think of Dyneema. These two right here, those are for water throw lines. They're the ones that float. They're not really good for rigging anything. Predominantly, you'll see nylon, polyester, and HMPE. A couple of pictures of the splicing process for a rope. You can see tube and tube. That's why it makes it easy to be able to splice it together, and eventually this gets pulled into itself out that way, and it's a Chinese finger trap, basically. So this rope specifically, there's a video where it is a pull test. The rope originally is rated for 3,600 kilograms, and then they do a pull test with the spliced eye, and it breaks at 3,400 kilograms. So still very close to the rope's original strength. Whereas if it was a figure 8 on a bite, it broke at 1,200 kilograms. So a significant difference there. Getting into the gear itself, we have mechanical prusiks, mechanical rope grabs. What makes these great for the arborist industry is that they are midline attachable, whereas with our typical descent control devices, if you have a tensioned line, you're not going to be able to put a clutch or a pencil ID or something on there because it requires a significant bend in the rope. These, you can do that. They all have these little hooks on them that you will clip to so that when you're climbing up, it slacks and it plays up the rope. And then when you sit down, it bites down on the rope, and it's a progress capture that you can then descend down on. With normal friction hitches, like a triple wrap prusik or something like that, if you were to put your whole weight on just that, you would not be able to release the tension. These are all designed to be able to do just that. So these are great for the arborist industry. The unfortunate thing is that they're not necessarily great for rescue. None of them in existence in the industry right now are rated for more than one body weight. This one specifically says it there on the package itself. So you wouldn't be able to put 2 people on a single one of these devices. The Petzl Zigzag currently is the most popular mechanic prusik in the industry. You can see this is the grabbing part. This has an internal pulley. So you can do that moving rope system that goes up and then clips back to this point. Or it can be a single rope system where it goes up this way, and then you have Petzl's version of a rope grab, or a rope wrench up here that would help to limit the forces exerted on this mechanical prusik. Petzl's being Petzl, and so they say if you're using this Petzl Zigzag in this configuration, you have to use their rope wrench. They don't certify using any other type of rope wrench, which is silly, but that's what they say. And then this is what a lot of people will use. You have a pulley for when you're climbing up. It pushes the hitch up with it, This is the moving rope system where it comes back to itself. And then you have the single rope system where you have the rope wrench there, climbing hitch, and then the hitch pulley. Foot and knee ascenders. You have a rope grab that's going on your boot. You have a rope grab that is going on your other foot and then gets clipped up to your harness or to your chest point. And the rope grab portions are offset. So knee ascender is going to be up here, foot ascender is down here. Reason for that is you'd be able to step up to your knee ascender, step down on that, and then when you step up on the left side, the knee ascender slides up because it's attached to a bungee. And so you're able to step up, step up, step up, step up. That system is called a rope walker system. And if you have a long way to go, that is a very fast, effective way of getting up on the rope. Savers will also do that for multi-100-foot pitches that they have to ascend. Friction savers help to save trees. So this will go over a branch and your ropes would go through these two rings. These rings are different sizes because you would be able to pull your rope back through and have a little dongle on them that will catch on this side. So then you're able to pull your rope down and this will come down with it. So it's remote retrievable is what the term is. And this helps to make it so that you can get up the tree a little faster, a little smoother, and it again protects the tree. Bull ropes and rigging ropes, bunch of different makes of ropes, designs of ropes, but they are very strong, very static, not a lot of stretch at all, and they are going to be used for grabbing trees, pulling trees down, or catching branches and lowering them down to the ground. This is called a porter wrap. It is a device where you can wrap your rigging rope around this multiple times for friction, and then that would go up to the branch that's going to be brought down, and then you've got somebody back here tending the rope so that when the branch gets cut off, it falls, and then they just let the rope play through and it gets lowered down in a controlled manner. Lanyards and flip lines. This is going to be what somebody is required to have going up in the tree, because you're going up on rope. You get to wherever it is you're working, you would have a second point of attachment beyond just your rope, and that would be your lanyard. You would throw it around a branch around you, whatever it might be, so that you have redundancy in your system to keep you safe. And then arborist harnesses. You can see the main difference for arborist harnesses and what you would typically see on rescue personnel is that the padding is typically going to be a little bit thicker and wider because they're working in a harness all day. That's their job. And then they have what's called a rope bridge here. And what that does is it gives them significant mobility in being able to twist and reach to something. Because if your rope came down to your ventral connection like a typical harness would, if you try and turn this way, it's going to catch and you're fighting it. However, if it comes out to a rope bridge that has this much movement, you'd be able to turn and it would go that way, making it significantly easier for you to reach around wherever it is you are in the tree. And so these are really fun. They are very effective and they're very comfortable by comparison. So that is our general introduction to the arborist industry, the gear they use, and the type of rope that they will use. If you have any questions, let me know, and I appreciate your time.